Hello everyone. Today I will be showing you how I make my tin stripping solution for removing tin solder from pins and sockets. For the solution, I will be using 60 grams of citric acid powder, 60 milliliters of 12% hydrogen peroxide, and some water. 20 milliliters of nitric acid could be used instead of the hydrogen peroxide if you like, but I'll be doing this indoors. When using nitric acid, the experiments should be done outside or in a fume hood, as small amounts of nitrogen dioxide gas will be produced. This is a simple but effective solution. Simply add all the ingredients together, stir it all up, and add it to the material you wish to strip the tin from. Here I have some pins and pin sockets that I wish to remove the solder from. To recover the gold plating from the pins, I will be dissolving them in nitric acid. If I were to leave the solder on the pins, it would react with the nitric acid to form metastannic acid. Metastannic acid will clog up the filter when it comes to filtering. This solution is effective at room temperature. At room temperature, the reaction takes around 24 hours, but if you add a little heat, that time can be reduced to a couple of hours. With the temperature set on a low setting, it doesn't take long for the reaction to get underway. So what is happening inside the reaction? To remove tin solder, hydrogen peroxide acts as the oxidizing agent, and citric acid acts as a chelating agent and a mild acid. The combination oxidizes the tin and dissolves it into the solution. The hydrogen peroxide serves as the primary oxidant in the mixture. It converts solid tin into tin 2 ions. Citric acid acts as a chelating agent, which binds to the newly formed tin 2 ions. This chelation is crucial because it pulls the tin ions into a stable, soluble complex with the citrate molecule, preventing the formation of tin oxide. The chelation process effectively dissolves the metallic tin from the solder. Without the citric acid, the tin ions would form an insoluble tin oxide passivation layer on the surface, which would stop the etching process. When the mixture is heated, several effects enhance the reaction and speed up the solder removal. Higher temperatures provide more kinetic energy to the molecules in the solution, causing them to collide more frequently and with greater force. This accelerates the rate of oxidation and chelation reactions. Heat generally increases the solubility of salts and complexes in a solution. This ensures that the tin citrate complexes remain dissolved and do not precipitate out, which could otherwise slow or halt the reaction. The primary drawback of heating is that hydrogen peroxide becomes unstable at higher temperatures and can rapidly decompose into water and oxygen. This decomposition can lead to an uncontrolled exothermic reaction and reduce the effectiveness of the solution by depleting the oxidant. This actually happened in this reaction. I accidentally left it to get too hot, and it decomposed the hydrogen peroxide. This isn't much of a problem. Just allow the solution to cool for a short while and add a little more hydrogen peroxide. As you can see, there is still a little tin left on these pins, so I'll add another 30 milliliters of hydrogen peroxide. After another 30 minutes and a couple of water rinses, all of the tin is dissolved, and these pins are ready for a nitric bath. This whole process took around 2 hours in total, and I was able to do it indoors out of the rain and bad weather we're having at the moment. If you've enjoyed this small informational video, please give it a thumbs up, and I'll see you in the next video where you'll find out where these pins came from.